Assalamualaikum and hi, we are from company Foresight Construction Berhad. We want to share about our new project, Pedestrian Bridge. This is our company team. First, Nur Fatihah Atika binti Muhammad Fazil. Second, Aida Sahira binti Nur Muhammad. Third, Chong Jin Pang. And the last one is Choi Monkey. Our content for this video contributes introduction, theory, proposal design concept, methodology, materials, calculation, cost estimation, and the last one, discussion and conclusion.
Okay, like before, our presentation was state that our location is Kampung Jawa, Ayer Baloi, Pontian, Johor. So the problem statement is still same and the objective is still same. To calculate the internal force in each member of the bridge under the effect of the weight of the bridge and roadway, the dead load and the weight of the vehicle, the live load are likely to cross the bridge. Okay, create a structural optimization algorithm capable of finding the various reactions when subjected to various load combination and design constraints, comparing and analyzing the truss bridge model. Okay, let's proceed with the theory. Okay, the theory start with the design of the bridge. Okay, the design of the bridge that we choose for this project is pad truss bridge. Okay, pad truss bridge is a triangular truss with a diagonal members that slope toward the center of the bridge. So at the screen, we also can see advantages of the pad truss, disadvantages of the pad truss, and why pad truss bridge is the best to use for this project. Next is about free body diagram. Okay, free body diagram is illustrating the relative magnitude and direction of all force operating on an object in a given condition. So we can see that in the diagrams that free body diagrams has support and also the load in the structure. Okay, we proceed to the bend stress. Bend stress is a beam deforms when it is subjected to a loading system for a force couple acting on a plane passing through the axis. The beam deforms as a result of the shear force and bending moment. Flexural stresses are the usual self stresses caused by bending. So we also can see the beam bending stress formula that used for get the bending stress. So next is deflection. Okay, deflection is a beam deformation, is often described as a deviation from its initial unloaded position. The deflection is measured from the original natural surface of the beam to the distorted natural surface. So the method to get the deflection, we have two methods, which is double integration method, also the moment area method. Okay, we proceed to another theory about compression member in column structure. So, structural elements that are subjected to axial compressive force only are called columns. Columns are subjected to axial load through the centroid. Smaller compression members are sometimes referred to as trunk. So, we can see the pictures show about the critical buckling load formula and um, has a one formula that use the K value. So we can see that another type of the attachment can have a different theoretical K value. Last but not least is truss. Truss is a regulated system of members that are structured and connected in a way such that they only incur axial force. These members are considered two force members as a force are only applied at either end of the member, resulting in either a compression or tension force. So we can see have a lot of types trust of the bridge, and if we want to know that the trust is statically determinate or not, we can use the formula, which is m plus r equal to 2j. Okay, thank you.
Next, proposal design concept. This is the proposed design concept for our company for a pedestrian bridge. The software we use to create our design is AutoCAD. The design we recommend is based on durability, and our company is very concerned about safety. The proposed design has two views, namely plan view and side view, and there is a description for our design, also includes dimension. This is a simple design for our design concept. Next, methodology. This is our flowchart for our project proposal. Our flowchart is focused on design project, start at project idea and proceed to constraints and market our cost analysis. In constraints, there are two types. First, non-technical and technical. At non-technical, there are two, economical and sustainability. And at technical, there are three, clearance, loading, and accessibility. If constraint okay, we proceed to preliminary design. Same goes to market or cost analysis. After that, we proceed to cost analysis, feasibility, and finally to final design.
Next, we will discuss about the material part. In the material part, we have beam, bridge deck, truss, and the column. Different item, we will using the different material to build it. And also, we can see the material in the figure that we show below. Thank you. Next, we discuss about the calculation part. The live load that we got is 0.57 kN per meter, while the dead load is 7.014 kN per meter. So we can get the total load is 10.32 kN per meter. From the free body diagram, we can calculate the reaction force is both same equal to 77.4 kN. The inflection point is equal to 7.5 meter and the required section modulus is 0.0172 meter cube. Also, we can get the graph of SFT and BMD below the figure that we have given. Thank you. Also, the same part, in the thrust analysis, we can get our thrust is the statically determinate thrust. Besides that, the support reaction for both sides we got the same value, which is 17.05 kN and the degree is 45 degree. Lastly, we using the method of joint to calculate the member of thrust. By using the method, we can know which thrust is compression or tension. Last but not least, for the column analysis, we will use type of method to calculate, which is the Euler method and secant formula. But in the Euler method, we can get the stress is exceed the yield stress. Therefore, the application of Euler equation is not appropriate. After we using the new axial load P equals to 1.875 times 10 power of 7 Newton and calculate by secant formula, so we can get it appropriate. So we conclude the value of allowable eccentric load is equal to 1.875 times 10 power set of 7 Newton. The next part is cost estimation. The project initial cost is 1 million. The management cost is 200,000 and 304. Total utility cost is 49,500. Total machine and tool cost is 13,000. The total logistic cost is 184,800. The total labor cost is 175,000. And the lastly, total raw material cost is 292,000.
As a conclusion, the bridge are an architectural structure that are usually built over the road, river, or railway. And we choose the Just Design Bridge as our design. As safety is the priority, we just estimate the light vehicle and human walks go through the bridge. And we can conclude that our bridge design is estimate the total length with 15 meter, maximum wide width 3 meter, and maximum height with 2.5 meter. And lastly, the materials that we use are reinforced concrete and steel because both of them easy to find and are last longer.
That's all from us. Thank you for your cooperation.